So thanks everyone for attending this talk, and thanks Black Hat for inviting us as well. The first thing I want to tell you is that this was supposed to be a two-man's talk, so Will was not able to come here because he had other things to do, so unfortunately he's not going to be here, but I'm going to do the presentation. So let's start. First of all, disclaimer, which is in every presentation. I'm going to do a very quick introduction on me and the company, for those of you who don't know Onapsis and what we do. This is a company focused on business-critical application security. So we focused on applications such as SAP, Oracle, PeopleSoft, JD Edwards. So we understand that these applications are very critical and are holding the business crown jewels. So we do a lot of things around its security, develop software, provide services such as pen tests, hold trainings, research, report advisories, well, a lot of activities that then allows us to do this kind of presentations, technical presentations in this kind of conferences. So who am I? My name is kind of a long name. It's Juan Pablo Perez Echegoyen. So for you, it's just JP, because I had all sorts of different combinations of my name. So just for easy, to make it easy, it's JP. I work at Onapsis pretty much since the beginning, doing research. My background is coming from doing pen tests and doing research on different products, SAP, Oracle, and other products as well. So it's a technical background. Well, having said that, let's jump into the presentation. This is the agenda for today. We're going to do a brief introduction into the in-memory platforms or in-memory databases. Then we are going to talk about SAP HANA, and then some threat or attack vectors to SAP HANA. And well, you have all those there, and we're going to go through each one of them. And then we are going to draw some conclusions for you to take out of this talk. If you're running SAP, or if you're running SAP with HANA or have HANA applications, then I think you will find this very interesting. So the first slide that I wanted to present is an introduction to in-memory databases, right? So, but then I started thinking and I realized that it's a very simple concept. If you think about it, it's a database that is running in memory, right? It's doing all the processing of the tables, all the queries, modifications, changes, everything to the tables that are stored in the main memory, right? Not in disk. Even though there is disk storage holding the data and the tables, all the tables are sent to the main memory and needs to be able to be held on the main memory in order to be processed. So that's basically the concept. It's not such a new concept. It's something that has been going on out there like since a long time ago. Even if you go to Wikipedia, you will see that there are many products around in-memory databases. Then we started seeing, a couple of years ago, we focused heavily on SAP, started seeing HANA and started talking about HANA. And we realized that this is something that's getting a lot of attention, and it's really growing. But it's not just us who is saying that, right? So Gartner is also saying that as well. And we actually see this. We see this every day with the new implementations, with new customers. So why didn't it happen before? Well, there are some things that helped this happening. It's in the last part, but I think it's very important, the innovation part, right? So these kind of things are coming not so related to main product lines, but usually from the research labs of the companies, right? So, and this is what happened with SAP HANA as well. So it's something that is driven by innovation itself. Then we have also cost of physical memory going down, right? So we know this, we see this every year. We know that it's not the same have 16 gigabytes in our laptop right now that it was 4 years ago or even earlier. So it's going down. This is making things possible to have like servers with 256 gigabytes, 1 terabyte of memory, of RAM memory, right? So this is what we need actually to run these kind of databases. And then also there is an important push from the business itself. So we are usually familiarized with business applications, ERP, CRM, business intelligence, SCM, all these kind of business applications that I will talk about later. But these applications are growing not only in terms of the business processes that are being processed through those applications, but also in terms of the data that is being managed. So a report that usually took 60 minutes or 6 hours to be generated because it was using a lot of tables, querying a lot of information, now with this kind of technology can be generated in a matter of minutes or even seconds. So there is a big push out of the business in order to achieve this, right? Well, we have some vendors involved into this in-memory databases. We have Oracle. These are the usual suspects, right? So we have Oracle, we have Microsoft, we have SAP. These are kind of the most well-known vendor of business applications. Oracle is very dedicated to databases and also has a lot of products in terms of business applications such as Financial, PeopleSoft, JD Edwards, Siebel. So all those Fusion framework, all those applications are running around the Oracle database. But Oracle 12c is the first one on providing in-memory features. And then Microsoft also, as you can see, Microsoft SQL Server 2014, so it's kind of new, right? And also Oracle 12c is new too. I don't know if it was released already or not, but this is something very new. But then we have SAP HANA. SAP HANA has been around here around 2011, something like that, when it was started to being implemented on customers, on pilot implementations, on different deployments. So we are going to focus on SAP HANA, and I'm going to tell you why. So just to illustrate this, what I'm saying is something, for example, from Oracle, and this is exactly what you will get from the internet and what you feel, right? It's orders of magnitude faster. It's like the difference between walking and flying in a plane. And if you see comparisons, you will see that it's true. You will have reports, you will have results way faster than with any other architecture like typical database, right? In-memory databases are way faster. Also, around innovation from SAP, another quote. I really like this one because I think it's very illustrative in the sense of what this actually means in-memory computing for SAP. Like you had the traditional approach that we will see also, where the user or the application layer is on top, and then you need to go and grab the data from below, right? But in the in-memory computing, you have this blended architecture. That's what we're going to talk about. This in the same layer, you have the application layer, you have the web applications, you have the users, the authorizations, and the data itself. Everything in a single product. And finally, this is just to show you some real-world examples, right? SAP is pushing towards SAP HANA, providing a lot of products such as ERP, CRM, all the business suite, a lot of products around HANA in terms of analytics. For example, this is after Germany has won the World Cup. This is actually SAP saying that they were using SAP HANA to do the analytics. I'm not so happy about this because I'm from Argentina originally. So if you remember the final, well, you know it's not so good, but I think it's a great example to show that this is something that is being used by customers. There are a lot of companies actually implementing and in the process of migration to SAP HANA. So that's, this is what I wanted to show you with these quotes and examples. So let's talk about SAP. Anyone running SAP, doing pen test to SAP, auditing SAP, familiar with SAP? Okay. You're a little bit shy, but no worries. SAP is everywhere. SAP is in the biggest companies in the world, is the biggest provider of business management solutions. If you go to, and it's not for SMBs, right? Even though it has solutions for SMBs, for small and medium businesses. It's in the biggest companies in the world. If you go to one Fortune 100, Fortune 500, Fortune 10, all those companies, most of those companies are running SAP software and are running the most critical business processes on top of this. And just some numbers for you to get an idea of not only the size of the company itself, but the size of the implementation. From an attacker standpoint, it's the size of the attack surface, right? If you see, like, Microsoft is being researched all over the world. You will see advisories and exploits everywhere because the attack surface is huge. Well, SAP also is, there are many implementations out there. So even where an attacker would think is that that's a big attack surface, and the criticality of this is even bigger. So it's not in SMBs, it's in the biggest companies in the world, and those companies are running that kind of processes, right? Treasury, invoicing, sales, production, procurement. That's critical business information that is being stored and processed by these systems, and HANA is being used for that. So why is it so important, and why did we focus on this? Because we started focusing on SAP and Oracle applications, but then we also did research and started to analyze HANA. And the reason for this is because HANA is SAP's star product, right? So whenever there is a new implementation, SAP is going to push for this implementation to be implemented through HANA, right? By implementing a HANA database and not, for example, an Oracle database. So that's one example. Then you have a lot of new products, a new product line supported by HANA as well. So there is a lot of movement within SAP in order to push HANA, and it's really, really important for SAP to do this. Migrations also are planned to go from the typical databases such as Oracle, SQL Server, DB2 into a HANA environment. So, and I'm going to quickly finish with the introduction. What I want to show you here is that we are talking about SAP systems, we are talking about in-memory databases that are processing business-critical information, right? So, in this sense, we are not talking about someone just exploiting a vulnerability and having a root shell account, but we are talking about someone exploiting a vulnerability and connecting to a database and retrieving business information such as customers, vendors, human resources, engaging into an espionage attack. Also, we are not talking about, I don't know, a denial of service, someone fuzzing a protocol and breaking up a service, right? We are talking about someone fuzzing a protocol and breaking up a service that is supporting business-critical process, right? So someone would paralyze the operation, like by breaking up an interface, by breaking up a connection between two SAP systems, or just shutting down the whole SAP system. So that's a sabotage attack. And finally, fraud attack also, if a user is, if an attacker creates a user with high privileges and access bank account numbers, credit cards information, modifies some address, some vendor information, creates a new employee, all those attacks can be possible, can be made because of the nature of the information that is on those systems, right? So in this slide, what I want to emphasize is the fact that we are not talking about just exploits or vulnerabilities, we are talking about business processes that are supported by this technology. So let's jump into SAP HANA. SAP HANA is an in-memory database, but what's really important or really interesting of this part is that it's shipped with an HTTP server. And you have this integrated into the database. So whenever you develop, as a developer, you create a new application for SAP HANA, we are creating an application that's running on top of the database, but integrated with the same users. So that's very important to understand from an architectural point of view. Then there are integrations with external applications such as calc engines. I'm going to show some examples about an integration to Earth server, on how that can be actually tricked into achieve something. And what's important, again, is that it is supporting business applications, right? It's not just a standalone database. It's not just a standalone web server. It's something that supports and holds real business information. So why do we say that this is a blended architecture? So all of you that usually analyze web applications or do pen tests, I used to do also web application pen tests a long time ago as well. We know how this works, right? Typical web applications, and also SAP NetWeaver runs in a very similar way. Typical web applications are configured in a layered approach. So you have the users and the application layer. Then there is a connection from the application to the database, which is usually a single user. That user is usually configured to access all tables and everything within the application. Anything that should be reached by the application should be reached by that user. And then we have an operating system user that is actually the user running the database itself. So it's a layered approach. And if someone wants to break into that application, he will be able to jump between the layers, like exploiting a vulnerability, for example, an SQL injection, jumping to a database, and then jumping to an operating system, depending on the vulnerabilities that are affecting that application. So in this scheme, we have a single user on the database and a single user on the operating system. So, but we have several users connecting to the web application, right? However, in this blended architecture, we have a different approach. We have database users or application users, it really depends on how you see it, which are authenticating to a database. And as this is integrated, we have a same source of users connecting through HTTP or maybe through SQL, right? So all the users are the same within the database and within the application server and the web application. Then there is like another layer, which is the operating system that is supporting or executing all the HANA services and providing like an interface for function calls and all that. So it's a different approach. That's why we call it a blended architecture. That's because instead of having different layers, we have now two layers that are integrated into a single layer. So now this is going to make some vulnerabilities, the impact of some vulnerabilities, a little bit different. For example, and what's really interesting here is there's kind of a reversion, right? And I'm going to explain you why. In typical web apps, an SQL injection, depending, well, it really depends on the vulnerability itself and other factors, right? But usually the user that was used in order to execute those queries and inject the SQL commands is the single user, right? So that user has full access to all the tables. Therefore, an SQL injection usually ends up meaning a full system compromise or full application compromise. It really depends on the vulnerability and some other factors, but this is the typical approach. However, in HANA, we have a different scenario because we have a web application that is integrated into a database. So the same user that logged into the application is the same user that is executing any query if there is an SQL injection, for example. So it's really up to the authorizations of that user. It's no longer a single user with full authorizations to all tables. So the criticality of these vulnerabilities tends to be lower because you need to mix it with some social engineer to get a full privileged user, right? To trick some user to do that. However, cross-site scripting in typical web applications is something that needs to be mixed with social engineer. You need to target the user. You can steal the session. You can do different things depending on the programming language, on different factors, right? However, now with this blended architecture and the integrated, there is a feature that is by default on every HANA system that I'm going to describe later. But with the default features, this tends to be more critical because having a high privileged user would lead to an attacker being able to modify any page within the HANA system, right? It's a matter of targeting the right user and having just the feature is there because of the IDE that is provided by default, but it's a matter of targeting the right user and a full system compromise could be achieved. Then some other facts. For example, the code is stored in the file system typically. It really depends, but usually it's stored in the file system. However, in HANA, we have the code within the database, and we will see which are the queries that we need to execute in order to get the code itself. And actually, it's a code that can be changed within the application, right? If the right SQL query can be executed, the whole code could be modified. Another fact, in terms of OS commands, is that SAP really restricted the command execution within HANA. So these two layers that we see here, the jumping between the DB layer and the OS layer is very, very difficult. There is no feature to do that, like no valid feature. So if there is a way to actually execute OS commands, that's a vulnerability. But by default, you don't have any feature that allows you to jump into operating system like you have with stored procedures in other databases, for example. So it's restricted. Some more concepts around HANA, and then we will jump into the different attacks. There are different programming languages provided by HANA. By default, we have a very complex stack, different languages. For example, XSJS is JavaScript, but server-side. It's based on SpiderMonkey JavaScript, so it's something well-known out there. We have SQL, SQL script, R code, and L code for internal procedures. So we can actually write a procedure in R, and that will be executed externally in a different system. So that's possible. ABAP also, we can code specific ABAP code that is tuned for HANA to work faster. And then HTML5, we have all this mobile stack that is available in order to develop mobile applications as well. So this is just an example, right? We have more programming languages as well. SAP is providing a lot of tools and trainings and courses and a lot of information in order to make people start coding on top of this, right? And to make new applications. And this is important to understand some of the further attacks. We have two ways into how to create new code within SAP HANA for web applications, right? One is the HANA Studio. That's the kind of the database client. We get the package, install it, and connect to the database. We can modify any artifact. We can create new web applications, create users, do whatever we want. That's the HANA Studio. But on the other hand, we also have the XS IDE. This is an embedded IDE, which is by default on every HANA implementation. So if you have enough privileges, you can actually create a web application through the web browser, right? Connecting to the port 8000, this is the default URL in the 8000, and that's the URL. But if you have enough privileges, you can modify code, create new users, do whatever you need to in order to administrate the system. However, on the other side, an attacker being able to connect to this, if he got some credentials, he will be able to also modify things as well. So let's talk a little bit about the threat or attack vectors to SAP HANA. This is the difference between a typical SQL injection and an SQL injection that is being triggered within HANA. On one hand, we have the HANA code, and on the other side, we have a PHP example. And you will see that the first difference is this single authentication or single user that is being used when you code an application, for example, in PHP, right? So the user is connecting to a database. This could be stored in another file, whatever, but the queries are being executed with this single user. However, in HANA, we have this statement, db-get-connection. There's no username, no password. That's basically saying, hey, I want to get a connection to the database using my user, right? So that's what's going to happen. There is no exchange of credentials. It's only the user that was already authenticated to the system that will be executing that sentence. And you can see that both applications are vulnerable to SQL injection. So this is just an example for you to see the differences of both approaches. So when it comes to SQL injection, it's not only about what's being executed or what can be appended to a string, how we can exploit this, how we can trigger the SQL injection. It's not only about that, but it's also about who is actually triggering that, right? Because it's not the same if I have a user, valid user, and I detect an SQL injection and I trigger that within the application, I can have completely different results if there is another user triggering that same vulnerability. So it's not about what's being executed, but also it's about who. So social engineering attacks are very, very important when it comes to, for example, doing a pen test on this kind of implementations, right? So I'm going to do a quick demo on SQL injection on HANA. Okay, so this is very quick. This is an application on HANA vulnerable to SQL injection. What's happening here is that there's a parameter. It's being injected with a true sentence. That's okay. There is a single record in the table. However, we can append something to get the database version, for example, and that's what we're going to do in order to have additional information. All this information is also in a pentest cheat sheet that is provided by the end of the presentation, so you will be able to see which are the commands that are useful in order to get additional information. So there's nothing strange on an SQL injection. It's a matter of knowing which is the injection point, which is the information that we're going to get, the version of the database, making a union with another table. There's nothing strange with that. However, there is something that we saw in terms of the tables that are configured within HANA that is called time travel. And that's not something that we created, right? The term is already being used for that functionality. So I don't know if you remember this screen or even this movie. So what we're going to do is I'm going to show you that there are ways into getting information from tables that shouldn't be there or apparently is not there. So there is something that is called history tables. And history tables is a concept very simple. It's basically are tables whose information is never being deleted, but it's being kept track of all the changes, right? So for example, with an initial table like the one we have in the upper section, we have 3 rows. However, if we update one of the rows, we will have an additional row with the change and the original modified. So we have a new row in the table. But we will have different valid from and valid to. That's shown as dates. In the real table, it's actually not a date, but a commit ID. So, but just for you to have an idea, a date is good to understand. So if we delete something, now we see a different record whose validity also changed, right? So it changed. Now we don't have a question mark. That means that if we want to query the table, the current state of the table is going to have only the records whose valid to date is not being shown. But all the rest of the records are still there. So let's say that we want to keep confidential information or very sensitive information in a table, and we want to keep track of that because it's important information. Well, through an SQL injection, someone with access to the table would be able to gather all the table, all the contents. And something to keep in mind is the fact that we need to specifically delete the information, right? So it's not something that gets automatically deleted or nothing is deleted until we specifically say so. So there is a command that I'm going to show you also. So conceptually, time travel tables or history tables are tables whose status is being changing over time and all the changes are being recorded. Some commands for you to keep as a reference: how to create a history table, how to list history tables. This is important because if we want to know if we have such a table, we need to execute that command. And then if a user wants to access all the table, like the current status of a table, that would be select star from table, right? But if we want to get a specific status or a specific commit ID, that's the technical term, if we want to get a specific commit ID, we can specify that and we will get the table as it was in that specific date. So that's something we can get. And also, there is another way specifying request flags, like request flags or rows, that's another way. So we are not getting a specific commit ID, but we are getting the whole table. So we will have way more results. And finally, to delete the history information, that should be the command. I haven't tested it, but that, according to the documentation, that should be the command to delete all the commits that are not the current one, right? So let's see a more interesting SQL injection. So what we have here is a user connecting to the IDE, the web interface. So he's authenticating to the system. He will actually access all the catalog and will be able to see all the applications and will see the vulnerable application and the tables. So that's what he's doing right now. It takes some time. Something to say is that unfortunately I cannot run a HANA system on a laptop because it will require a lot of memory, so I had to record the demos. So the user is connecting to the IDE, to the IDE. He's accessing the catalog. He will show all the information. Let's move a little bit. So he can get a SQL browser, for example, and list all the tables which are type history. So this is on the valid user side, right, to check all the history tables. So we see accounts, that's a history table, so that there might be something interesting there. But on the other hand, we have an application that is actually connecting to that table and showing all the information. So in the IDE, we have the onApsys package, which holds some applications, some vulnerable applications, some applications that we developed for testing. And this application specifically is very similar to the other one, to the one vulnerable to SQL injection. It's something that gets a parameter, it's being put together with the query, and it's being executed. So conceptually it's very similar, but what I want to show you is the difference that we get when we execute an SQL injection, traditional SQL injection, or when we apply some of these modifiers. So now it's We are not providing any ID parameter. So once we provide the parameter, we have the ID1, we can have the ID2 as well. Those are the only 2 records, and we will be able to validate that, because if we add a true sentence, we will see that those 2 records are the only ones in the table, right? So if we don't know that that's a history table, that's it, right? We can stick to that. However, if we append that modifier, we will have additional contents that maybe were not supposed to be shown, or it's information that we don't want to be accessible, right? So that's possible. If we append some of these modifiers to list specific commit IDs, or even get the whole contents of the table. And then finally, as a user, what we are doing is showing this, the status of the accounts table. Valid 2 is not configured for the first 2. Those are the first 2 records, and we thought that these were the only ones, but then we have some others which were valid at some point in some commit. So that's basically how you trigger a time travel SQL injection with these historical tables in SAP HANA. So for each one of the attacks, I'm going to show you some countermeasures. Well, this is for the developers. If they are aware of these kind of vulnerabilities, it's probably something they know, but it's never too much to know all these kind of countermeasures. Use prepare statement, do not concatenate parameters that are not validated, and in the end, it's all about the user's permissions, right? So there is a new requirement which should be very, very strong on every SAP implementation, and that's permissions. Permissions now, before permissions were always very important, right? But now it's even more critical, because this is going to define the impact of many of these vulnerabilities at the web layer. So cross-site scripting. Very quickly, cross-site scripting attacks using this embedded or this default built-in functionality could be even more critical, right? Because having this kind of cross-site scripting, like this kind of script sent to the user, or being able to execute in the user side, targeting the URL that we see in orange, that's a URL in the IDE, right? So that's a URL of the application that can modify anything within SAP HANA. So if the user has sufficient privileges to do that, then it's a matter of targeting the right user and sending something like this, modifying or inserting or changing, executing any query within the database. So this is just an example for you to keep of what could be potentially a cross-site scripting attack within SAP HANA. Some other recommendations in terms, some other recommendations in terms of cross-site, XSJS code. There are different vulnerabilities that could be affecting XSJS code. For example, the eval assignment, that's a vulnerability that there is a vulnerability that ONAPSIS reported to SAP around eval as well. So SAP already published an advice, sub-security note. So SAP or SAP HANA customers could update their systems and get the patch for this kind of vulnerabilities. However, it's all about the code, right? So this was a vulnerability in the standard code. However, if you have developers creating new applications and they use the eval in an insecure way, then you have vulnerabilities again affecting the SAP HANA system. So all these examples are just to show you that even though you're coding an application in XSJS code, which is a server-side JavaScript code, the application, the whole application and the whole HANA system could be endangered if it's not properly coded. Again, some countermeasures for this. Restrict packages exposed via HTTP. a user is authorized to connect through SQL and to connect through HTTP, right? So we have authorizations to limit which users and which packages we want to restrict for end users through SQL, through HTTP, and through different mechanisms. So there are different privileges such as system, application, object, analytic, package, users. It's complex, but it's something we need to tackle and we need to take care of, because otherwise we can expose the whole application. Enable cross-site request forgery protection. Yeah, definitely validate all the parameters. So let's talk about the integration with R server. Anyone familiar with R language? Good, we have one. Well, I wasn't familiar with this language before researching on this HANA platform. It's used for doing things very fast, right? Analytics, processing, things that needs a lot of processing power. It's very well known in the academic field, so you will see a lot of papers and a lot of work in terms around R language. But as SAP HANA is heavily focused on analytics and processing and performance, it's provided an interface to R server for users to code procedures in that language. So this is a SQL sentence that is creating a procedure written in R language. In the red part, just we need to remove that and put the R language there, and that's it. So R server is going to be running in a separated host, right? It's not going to be, it shouldn't be running on the HANA system. According to SAP's recommendation, it should be running outside of the HANA system. However, I don't know, it's up to the user how to implement this, right? So there are some attacks to this R server integration, and because of the criticality of the information that is being processed, we want to emphasize on all these different attacks. So initially, this must be installed on a separated host. Therefore, from the SAP HANA itself, and probably from many other systems, there should be a remote connection to the R server. So the port needs to be listening to the network. And R server is also exposing high privileged functions like remote shutdown and OS command execution within the R server. So that's something you will find within the R server package. And then if we talk about authentication and also encryption of the traffic, well, must be configured with user authentication. However, there is not enforcement of that. It could be configured without any kind of authentication at all. And even if we configure user authentication, there is no protection in terms of password strength, in terms of brute force protection, or any other thing like that, because that's on the R server side. So depending on the type of information we are sending and receiving, this could be critical information, this could be business information, right? We might be sending something, some numbers to be calculated, but we can be calculating some forecast or some payroll, total payroll, or anything. Like, it really depends on how we design that and how we code that. So there could be sensitive information flowing through that. By default, there is no encryption, so SSL is supported by R server. However, I'm not sure if it's supported by HANA. SAP saw this presentation, so we didn't have any information about SSL. My guess is that it's still not supported, but it could be eventually at some point. So that information could be sniffed if an attacker gets access to the traffic, right? So let's see some more examples, specifically for attacks to R server integration. So this is the HANA Studio. This is the HANA client. If we go to browse the catalog and the objects and the packages, we will see that there is a procedure. It takes time. So we can browse the system schema, we can see the procedures, and we will see that there is a special procedure that could be coded in our language. This is myF and myF2, those are two different procedures. If we access the details of the procedure, we will see the parameters being sent and received, and also the code of the procedure itself, what's the definition. So once we have this information, we can see the parameters and also the definition, right? So we see language rlang. So this is a procedure developed around our language. So if we execute that, we will have the results. This is a very basic approach. This is where the R server is configured. It's just IP address, port. If we have authentication information, it's there too. So we can call the function and we will get the results. So we see that this is something that is actually running, right? It could be calculating anything around SAP HANA. So that's from our side, but what an attacker would try to do is he would try to connect directly to our server. For example, he's pinging that IP address that we saw before in the configuration, doing an nmap. This could be a broader scanning. This is just for that port. It's open. And there is a Python package that is called pyrserv. That Python package can be used in order to connect to the R server. So instead of going through the HANA, the attacker will try to go through the R server and connect to the R server. For example, now he's importing this package and doing a connection to the system. And after that, what the attacker is going to try to do is just do a shutdown, and that's it. The system, the R server was shut down, so whenever there's a valid request to execute this function, this is going to fail. So this could be breaking a valid business interface or something that is established or depending on this function. This is going through that side, right? However, let's say that the attacker compromised the SAP HANA, right? So externally, the attacker can shut down the system. But let's say that the R server is restricted, the IP address is protected by a firewall, there is user authentication, everything is running, is properly configured. So an attacker who has previously compromised the SAP HANA, what he could do is just drop the procedure that is already created and create his own procedure, right? Modify the existing procedure to do, well, apologize for the resolution, but what it says there, it's system net user jp the password /add and then net user local group administrators to add the user to a local group. So depending on the authorizations of that R server, the attacker could compromise the external system as well, right? Going through the R server protocol and creating a new user in the system. So after this, what happens is that once the procedure is executed, it will be executed running not only the code it was developed to actually run, but also the code that was added by the attacker. So this is just a validation of this. The R server is running. We will see that a call to this function now is not only generating the prime or calculating the prime numbers, but also something different happened on the screen, right? The user was created, and also the user was added to the local administrators group. So this is limited by the authorizations of the user, but it really depends on how this was implemented. If it's running as a service, as a system account, this will be possible. So the last step is the attacker that connects to the system. So let's skip that. He's connecting through terminal server just to validate that the user was created. So countermeasures, secure the R integration using SSL, configure authentication using strong credentials, restrict access to R server using a local firewall, use low privileged accounts. So all these recommendations needs to be taken care of, because otherwise, either through R server or through HANA, this could be abused, breaking up a valid interface or even compromising an additional system. Restrict shutdown and system. I know that it's possible to restrict shutdown. I don't know about system. Maybe some expert on R server could comment on that. But if it's possible, we should do it. Last of the threat vectors is that, as I said before, SAP HANA is restricted from an OS command execution standpoint. There is no way for a valid user, even though the user is administrator, to execute OS commands at the operating system level. However, there are some ways to interact with C code, right? For example, XSCFunc is a way to actually define a web application that calls a library in the operating system. And then we have the AFL that are also libraries that are shipped by SAP in order to extend the functionality of the SAP HANA system. So these are two ways that we have to interact with the C code. What we have found is that if the user is able to just put a library or control a file that is put in the HANA system, so there is this is a post-exploitation attack, right? So he needs to be able to put the file or the library in the SAP HANA operating system. But if that happens, then it could be possible to actually execute commands, because the attacker will be able to define a web application calling that library, right? So in this quick example, what we see is there is a netcat that was opened in the laptop of the attacker, right? Then the attacker creates this XSCFunc pointing to the library that he uploaded previously. So he controlled the library and placed it into the file system. So once the URL is executed, there is going to be an execution of that library, and then what happens is that a remote shell will be called to the attacker's laptop, right? So you can see here, user ID is HC01ADM, that's a HANA system, the system administrator, and that's an interactive shell that could be retrieved just because there was a previous exploitation or a control of a file that was placed into the application server. So as I said before, it is very restricted in SAP HANA, but if there is a previous compromise, there could be a way to bypass this, but that's how it works, right? We need to have a previous exploitation. So just to keep as a reference, Pentester cheat sheet, all the commands that we have been talking about, plus some additional for you to have how to get information from HANA systems. One that I would like to point out is to list the password hashes. So those are the password hashes of the users that are configured within the SAP HANA database and that can access both the web server and also database if they have the privileges. So let's draw some conclusions. Business critical applications, which are the crown jewels. We know that these critical applications are running the most critical business processes within our company, are supported by the latest technologies. So we need to catch up with this, and we need to understand how these technologies are better in many ways, but we need to secure them properly, otherwise we can be exposing the whole infrastructure. Within this new paradigm, it is critical to restrict the permissions of the users within HANA. So before this, it was very important. Now it's even more important because we are driving the impact of the different vulnerabilities. And finally, SAP HANA was built with a security focus in mind. So we see that because we have been learning about HANA, we have been researching about HANA, we know that this was built with a security focus, right? However, there are many responsibilities that relies on the administrators, on the users, on the developers, so we need to catch up with that too. And finally, this was included by the SAP Product Security Response Team, some references for you to keep, security guide and some white papers, some guides that I think you will find useful if you want to keep further learning about SAP HANA security. So thanks to the Synopsys Research Labs team, they helped me a lot with the demos and the research as well. Unfortunately, Will didn't make it for today, but he also helped a lot for the research and for the presentation. So if you have any questions, feel free to ask. I will be around here, so whenever you have a question. Is there any question? Okay, so you can go to Amsterdam and enjoy the city. Thank you all.